Hi and good day. Today I am going to discuss with you chapter Enzyme part B structure questions. Let's get started. Okay, in question number 1A, the question is explain how the shape of an enzyme molecule is related to its function. We are looking at enzyme, and normally an enzyme, it has various shape of active site. So these various kind of active site, one example, the shape like this, okay, will allow specific substrates, okay, whereby its structure has complementary fit or shape towards to the shape of the active site. Okay, so we can say that number 1, enzyme has specific shape right? Or it has 3D or three-dimensional structure. So each shape of the active site is specific to specific substrate. Therefore, number 2, we can say structure of substrate is complementary to the shape of active site. An enzyme. Thus, substrate can bind here to active site of an enzyme. Alright, so enzyme, it has 3D shape, it has specific shape, whereby its specific shape, it can fit to specific substrate. With regards that substrate, its structure must be complementary to the shape of active site to allow substrate binds to the active site of an enzyme. Okay, we move on to next question. So this next question show figure 1, and if you can clearly see here, this is an enzyme and there's presence of inhibitor. Generally, if you have a look at this enzyme, this inhibitor, it bound to the other side of an active site. So this is an enzyme with active site, and this is the other side of other than active site, known as allosteric site. So in this situation, this inhibitor, it binds to the allosteric site. What effect we can see? You can see now the active site of these enzymes change shape. So as this active site change shape, substrates that have a shape like this, a square one, unable to fit into the active site or bind into the active site. Hence, normally, enzymatic reaction is stopped. Why it is stopped? Because substrate now unable to bind to the active site of this enzyme. Therefore, no product. Okay, shall be produced. Alright, so now let's have a look on the following questions. Alright, so figure 1, explain how inhibitor can affect the rate of reaction catalyzed by enzyme. Okay, so how you want to explain it using this figure 1? Alright, so we can say this is a non-competitive inhibitor. Alright, why it is non-competitive inhibitor? Because we can see the inhibitor, it binds to the allosteric site. It does not compete with substrate, yeah, to bind to the active site. So we can say, because you need to explain, we can say that this is a non-competitive inhibitor, right? And then this inhibitor binds to allosteric site of this enzyme. And what happened after that? This causes a change in shape of active site. Thus, what the consequence would be in this case, okay, let me write down first. so substrate unable to bind to the active site. Move on to the next question. So this is figure 2. It shows the rate of an enzyme catalyzed reaction. So you need to draw a line to show the effect of competitive inhibitor on the rate of reaction. Just now, the previous question showed about non-competitive inhibition involving inhibitors bound to the other site of an enzyme. So in this case, when we talk about competitive inhibitor, so we are talking about enzyme that will have or will facing uh, two kind of binding. Okay, one is from substrate. The other one is from inhibitor. My handwriting is very ugly, yeah. So in this case, inhibitor and substrate, they're competing to bind into the active site of an enzyme. But because this is competition, normally at the end of the day, yeah, enzymatic reaction with inhibitor in competitive inhibition normally will achieve, okay, same amount of or equal rate of reaction. It's just that it's a bit late. Okay, all right. Now let's move on to the next question. So explain the effect of increasing substrate concentration on this enzymatic reaction without inhibitor. So without inhibitor, we can say more substrate, right? Um, bind to active site. Next, more enzyme substrate complex form so maximum products produce at maximum rate. So how about with competitive inhibitors? So we shall continue after this.